Hello friends! Today we'll be writing an algorithm for generating a random dungeon, commonly used in roguelike games such as The Binding of Isaac, Dicey Dungeon, Moonlighter, and Cult of the Lamb. In all of these games, the dungeon starts with an entrance and has a number of rooms leading to the end. But the rooms aren't typically in a straight line. That would be boring. The path through the dungeon twists and turns. Exploring this dungeon is still linear though, so they add branches off of the main path. All of this is randomly generated to create the final dungeon. When writing a complex algorithm like this, it's important to understand what it is you're trying to create, defining the exact rules and constraints which define it. Then breaking down the process into simple steps to tackle them one at a time. Constraints are the restrictions or limits that define what the final outcome could possibly be, such as the maximum dimensions of the dungeon. It's best to export these constraints as variables so they can be tweaked during testing. The dimensions of the dungeon will be a vector 2i for integer, and I'll give it a default value of 7.5. Meaning with these settings, the largest possible dungeon this algorithm will produce will be 7 rooms wide, 5 rooms tall, with as many as 35 possible rooms. In order to keep the algorithm efficient, we need to use simple data types to represent individual rooms within the dungeon, and we can store all of these rooms for our dungeon in an array. Since the dungeon has both an x and y dimension, it would be a good idea to organize the rooms into a 2D array, which we need to initialize to start empty before we start filling it with rooms. Overriding the ready function, we can start the first step of our algorithm, initialize dungeon, as a function, and give this function its own declaration. Iterating through the possible x values or columns in the dungeon map, we simply append an empty array to the dungeon to form the column. Then iterating again through the possible y values or rows in the dungeon map, we append what will represent a value of empty or nothing. I will use the number 0. We now have a 2-dimensional array with 7 columns and 5 rows of nothing ready to fill with rooms for our dungeon. But before we do that, we should have a way of knowing what is in our dungeon, so let's call another function which prints out the result of the dungeon generation. First declaring a variable to hold the dungeon as an empty string, we'll iterate through each row first, but start at the top row and count down to 0 since we read from top to bottom, then iterate through each column left to right. Appending the value at dungeon xy to the string, we can also do some fancy formatting like putting it in square brackets, then see how it looks running the scene. We can see the output is just a simple 7x5 grid of zeros. The next step would be to select a location for the dungeon entrance, which we will call as another function. Depending on how you want to constrain your dungeon generation algorithm, you may want to specify this as a specific location. So let's export it as another variable to act as a constraint and give it a value of something, like 30. Before using this as an array index, we'll need to check if it's valid or not first. To use these numbers as array indices, they must be greater than or equal to 0 and less than the dimensions. If the indices are valid, then we can use these to index the dungeon array and change the value at that location to something like s for start. But we might want to make this more flexible, allowing us to possibly specify a start position, but also maybe not. So if the provided index was invalid, then we can pick a random x and y coordinate anywhere between 0 and the maximum dimensions. Setting the default value of the start variable to -1 will have it be random by default, but also give us the option to specify a starting location if we want to, even allowing us to only specify either the x or y but have the other randomized. Running the game, we can see our dungeon's entrance marked with an S. The next step of our algorithm will be creating what is known as the critical path, the shortest possible path the player can take from the start to the end. The length of this path might be another constraint, as an integer. I'll give it a value of 13. Then we'll add another function to the list to generate the critical path, accepting this value as a parameter. This is an iterative process of adding one room at a time, starting from the dungeon's entrance. So we'll declare a variable to hold the current room, starting at the entrance coordinates, then another variable for the direction we are trying to go. Matching a random number between 0 and 3, we can set the value of direction to be up, right, down, or left. We then need to determine if the coordinates current plus direction are valid, or if they have gone outside the dimensions of the array. This will be a very long if statement, so it helps to break it into multiple lines using brackets. For the new coordinates to be valid, they must be greater than or equal to 0, and less than the dimensions of the array. On top of all that, the value at the new coordinates must be empty. If all of this is true, then we can change the value of current to be plus direction. Then change the value in the dungeon array to be something besides 0. Let's say the length of the critical path. We can then reduce the length of the critical path and call this function again, this time starting from current, which we will pass in as another argument and change the declaration to have the starting point as a parameter. This is called a recursive algorithm. It will break its task down into a simpler form and continue to call itself until it finds the smallest possible step to complete. In this case, it will be when the length of the critical path reaches 0, which we will check at the top of the function and return true, sending this information back to the previous step of the recursion that the formation of the critical path was successful. Changing the return type of this function to a boolean, we can put its function call in an if statement and respond to the return of true or false, success or failure. If the function returns true, that means the critical path is complete, and we can also return true. But if it returns false, that means the critical path failed at some point, and we need to reverse the changes we made here, setting the value in the dungeon array back to 0 and subtracting direction from current. This means that trying to form the critical path in the random direction we chose did not work, because there were not enough empty rooms in that direction to complete the path, so we will have to change the direction and try again. An easy way to rotate this direction vector is to reverse its x and y values and use the negative of one of them. Which one is negative will determine if the rotation is clockwise or counterclockwise. We will then do all of this again with the new value of direction. So wrapping it all in a for loop, we will loop a maximum of 4 times for the 4 possible directions. If this for loop completes without ever reaching the return true, then the formation of the critical path from the current location has failed, and we need to return false so the previous step of the recursion can reverse this change and try a different direction. Running the game, we can see that the critical path is generated with the desired length of rooms, counting down the length each time. Let's remove the empty rooms by replacing them with blank spaces and run it again. This is easier to read. As the algorithm is trying to create the critical path, it can box itself into a corner with not enough empty space left to succeed, and so it retraces its steps backwards and tries again in a different direction until the critical path is complete. A linear dungeon would be pretty boring to explore, so let's add some branches to this critical path, adding more constraints to the exported variables, like the number of branches and their length. Another use of vectors is for storing ranges with a minimum and a maximum value. This way we can have branches of varying length. I'll have 3 branches with lengths of 1 to 4 rooms each. To keep things efficient, it would also be a good idea to maintain a list of rooms which can have branches added to them as an array of vector 2i. Anytime we add a room to the critical path, we can add it to the list of branch candidates, then also remove it if the room is deleted. I would prefer if the last room of my path was not considered a branch candidate, so I'll add the condition that length must not be 1. The erase function will not cause an error if the candidate is not in the array, so there's no need to check first. Now that we have a list of potential rooms to branch from, let's add another function for creating branches. We will need to know how many branches we have generated, starting at 0, and the room we are branching off from, as a vector to I. Then while loop as long as the number of branches we have created is less than the desired number of branches. In the case of very tight dungeon dimensions, it might also be possible that the desired number of branches is not possible. So we can also add the condition that there are still branch candidates remaining in the array to prevent this from becoming an infinite loop. First, selecting a branch candidate at random from the list, we need to generate another path of the desired length. But we've already written the algorithm that does this. The only difference is that we are starting from a different room. We can then react to the result of the generate path function's success or failure, either incrementing the number of branches created, or removing the candidate from the list of branch candidates. We may also want to distinguish our branches from the critical path for further dungeon generation functions. So let's add another parameter to the generate path function, which is the value the rooms will be set to. For the critical path, I'll set it to the letter C, and for the branches, I'll set it to the number of branches created plus 1. Running the game, we can see that the critical path is marked with a bunch of C's, and each branch is numbered. I hope this video was helpful in getting you started with a procedurally generated dungeon. If you like game development content for Godot, please consider subscribing or joining my Patreon, where you will get exclusive content including full Godot development courses. If you have any questions or you'd like to see me try to replicate other game mechanics, comment below. I'm always open to try new ideas and challenges. I'll see you in the next video.